Archaeologists solve mystery of Terracotta Army's pristine weapons. The world-famous Terracotta Army of Zen is an array of life-sized, realistic ceramic figures representing warriors, stationed in three large pits within the mausoleum of Qin Shi Huang, 259 to 210 BCE, the first emperor of a unified China. Over 2,000 ceramic warriors have been excavated so far, and it is estimated that several thousand more remain buried. These warriors were armed with fully functional weapons made primarily of bronze. Dozens of spears, lances, hooks, swords, crossbow triggers and as many as 40,000 arrowheads have all been recovered. The preservation of the bronze is remarkably good overall, with many of the weapons displaying shiny, almost pristine surfaces and sharp blades. A new study, published in the journal Scientific Reports, reveals that the chemical composition and characteristics of the surrounding soil, rather than the chrome plating, once thought to be the earliest form of anti-rust technology, may be responsible for the weapon's preservation power. Since the first excavations of the Terracotta Army in the 1970s, archaeologists have suggested that the impeccable state of preservation seen on the bronze weapons must be as a result of the Qin weapon makers developing a unique method of preventing metal corrosion. Traces of chromium detected on the surface of the bronze weapons gave rise to the belief that Qin craftspeople invented a precedent to the chromate conversion coating technology, a technique only patented in the early 20th century and still in use today. Some of the bronze weapons, particular swords, lances and halberds, display shiny almost pristine surfaces and sharp blades after 2,000 years buried with the Terracotta Army, said Dr. Xiaozhen Li, a researcher in the Institute of Archaeology at University College London in the UK and the Emperor Qin Shi Huang's Mausoleum Site Museum in China. One hypothesis for this was that Qin weapon makers could have utilized some kind of anti-rust technology due to chromium detected on the surface of the weapons. However, the preservation of the weapons has continued to perplex scientists for more than 40 years. Now Dr. Li and co-authors show that the chromium found on the bronze surfaces is simply contamination from lacquer present in adjacent objects, and not the result of an ancient technology. They also suggest that the excellent preservation of the bronze weapons may have been helped by the moderately alkaline pH, small particle size and low organic content of the surrounding soil. The high tin composition of the bronze, quenching technique, and the particular nature of the local soil go some way to explain their remarkable preservation, but it is still possible that the Qin dynasty developed a mysterious technological process and this deserves further investigation, Dr. Li said. By analyzing hundreds of artifacts, the team found that many of the best preserved bronze weapons did not have any surface chromium. To investigate the reasons for their still excellent preservation, they simulated the weathering of replica bronzes in an environmental chamber. Bronzes buried in Zen soil remained almost pristine after 4 months of extreme temperature and humidity, in contrast to the severe corrosion of the bronzes buried for comparison in British soil. It is striking how many important, detailed insights can be recovered via the evidence of both the natural materials and complex artificial recipes found across the mausoleum complex: bronze, clay, wood, lacquer and pigments to name but a few, said Professor Andrew Bevan, also from the Institute of Archaeology at University College London. These materials provide complementary storylines in a bigger tale of craft production strategies at the dawn of China's first empire.